everyone, and welcome back to the Big Analytics Query. This time, we are talking about modern data engineering. We are joined by our very special guest, Daisy Kennedy. Daisy, welcome. Why don't you introduce yourself for us?
Yep. So, hi, I'm Daisy. I'm a senior consultant at Simpsons. Um, I specialise in both like data engineering and data science, but I think so stick to the data engineering side.
Well, thank you for coming on, Daisy. I think we will talk more about the data engineering, but we might have you back for the data science later. But in terms of data engineering, it's a big term that can mean lots of different things. Why don't you say, for someone who's not really heard the term before or doesn't know what data engineering is, what is data engineering?
So, data engineering is kind of the process of automating the sort of transfer of data between systems and like organising it all. So, in businesses, you've got loads of different systems like the finance system, um, HR systems, etc. And what we find in businesses is that they tend to like copy and paste bits of data from their system and email it across the different areas of the business, which
Doesn't sound great.
no, yes, and it's really time consuming and just kind of a waste of their time. So rather than like having people manually do this and kind of lose focus from what they're meant to be doing, data engineering is the process of kind of automating all that so that the systems can talk to each other and we can share data, collate it all together, and then like produce reports out the other side of that without having to have someone manually doing it all. Um,
Yeah, so it sounds like it's kind of the grunt work and all of the bringing everything together so then you can use that data.
yeah, exactly. Like let people get back to their jobs and
Yeah.
do what they're good at. They don't need to be copy and pasting data about.
Absolutely. Great. So now we've got the kind of understanding of data engineering and how useful it can be for businesses. We're talking about the traditional versus the more modern approaches for data engineering. Why don't you explain what the traditional approach might be?
So the traditional approach for data engineering is all very like SQL based. So SQL Server, and writing T-SQL store procedures to kind of make the transformations happen there. And it's usually orchestrated by something called an ETL, which is where you extract data from your data sources, um, transform it with your stored procedures, and then load it into your database or your data warehouse. But there's kind of been issues of that over the years where if you're maybe partway through transforming a table and then a transformation fails because, I don't know, something in the source systems change, or column names change, then you'll lose all of that data because you didn't actually land it into your data warehouse.
Yeah.
You were still transforming it. Traditional approaches, they tend to follow something called an ETL, which is like an orchestration template, if you will. It stands for extract, transform, and load. So it's basically you extract the data from the source system, and then while it's in transit, you transform it with your stored procedures. And then once you've got it kind of pretty or how you like it, then you'll land it in your database or data warehouse. But the issues with that is that if an issue happens while we're transforming it, you lose that snapshot of data. So if a new column gets added into a source system and it breaks your ETL flow, you'll lose that snapshot because you never actually landed it where you needed it.
So you lose it before it even gets to the end. So then in order to
Yeah.
fix it, you would have to rerun it all the way.
You would have to rerun it. You'd have to reload from the source system again, which you don't want to do during work hours because people are using the source system. Um, and yeah, it's just not.
But I guess there's the balance of you also do want to do it during work hours because your presentation layer or whatever the reporting periods are just wrong. So then people can't use that data.
Yeah, absolutely. So there's pressure to get it fixed quickly, but it's never really going to be fixed quickly because you're having to do the entire ETL, which, I mean, from places I've worked before, can take 8 hours to run from
Yeah.
start to finish. So yeah,
And that's, I guess, even if you know exactly where it's wrong, whereas often in big SQL and big company, like big SQL databases, big companies, could be a number of different places, I guess.
yeah, like you could find the issue. It could be something small, but then even then, when you do rerun it all, that snapshot is now going to be taken from 9:30 in the morning. So if any changes have happened that morning, we've lost any record of it. So if you're capturing change that's happening in your system, you're going to miss that because you're gaining it again in the morning.
So we've covered the more traditional approaches and what that looks like. Why don't you talk more about the kind of modern approach and what solutions there are to those problems that we've mentioned?
Yeah, so the modern orchestration route now is to go for something called ELT. So that's where you extract from your databases, then load your data into something called a data lake, and then transform it later. So benefits of that being that um, because your data lake is all file based, you're not trying to you don't need your data to be in a particular form to be able to save it off from the source system. So if a new column's added, it doesn't matter at that loading stage because it's just saved in a
Just into a
file.
file. So it doesn't break it later down. So instead of the ETL versus the ELT, you kind of have more error tolerance, I guess.
Yeah, and like if something does go wrong in your transformations, you've then got that security net that at least you've got the data there. So throughout the day, you can fix your presentation there and things, but you don't have to touch the source system again at all.
And I guess by fixing it at the end, it allows that whole process of the ETL to just, or ELT now, to run a lot quicker. Is the speed much better with more modern techniques?
Yeah, so speed of fixing it's quicker because you're not having to reload your data again. But it's also faster because when you're using a data lake, kind of the modern approaches for how you read from those tables are um, things like delta tables, and
Yeah.
they're kind of like a metadata layer above your set of files. Um, and that's really quick for
Yeah.
access. And
And I guess by having that, you can fix then problems a lot easier in the presentation layer because you don't have to run the whole process again the whole way through. And is the whole system quicker as well?
yeah, so exactly that. So fixing issues is a lot quicker because you're not having to load it again from the source system. So it's faster from that perspective. But also, like with modern data engineering, we're not using SQL Server anymore. We're using cloud-based, either Databricks or Fabric these days.
Yeah.
And these are like the processing power behind them is all distributed, um, and your code runs like parallel in a way. So uh,
So rather than one table at a time, suddenly it can do multiple jobs together.
yeah, definitely. The key technology behind how it can run it parallel is something called Spark. And if you like look into how that works, it's really cool. Um, but it's basically just massively speeds up all of that compute so that we're not waiting around for 8 hours to load a set of tables, we can get it done.
And the data lake is quite a new concept, although it's been around in a while, but people still, whereas you've got the on-prem SQL servers that have been around for ages. How easy is it to move things into a data lake and Delta tables?
Um, so yeah, it's definitely quite a big change, and obviously a significant amount of work to get us
Yeah.
to that point. But I think the benefits far outweigh that because when we look at kind of the issues with the older way of doing things.
And with those parallel jobs loading everything a lot quicker in the processes of Spark, as you said, because it's file-based formats, there's also the metadata driven. Does that speed things up as well?
Yeah, definitely. So that's kind of part of what allows it to be sort of parallelly runs
Yeah.
because when you've got metadata driven pipeline, that's you just have one pipeline that you're um, feeding in the different table names to and the column names to. Um, so that pipeline itself, we can split that amongst a load of different workers, and they each could be running, with different inputs. So this one's running for this table, and
Yeah.
then we can have all them running at the same time because the tables aren't dependent on each other at least. And to be on the same layer, we don't need to load them all.
So I guess that speeds up not only you don't have to query from the source system multiple times if something breaks in the process, those processes are individually quicker as well as overall being quicker.
Yeah, so like each layer of transformations is that much faster because we've kind of enabled Spark to be able to load all those tables and do all those transformations at the same time. So that just speeds it up massively.
And in terms of tools, you've mentioned Spark and Databricks and Fabric as well. What are the particular features of those that help make it so powerful?
So probably the best feature, I guess, that's different from the traditional approach is this kind of idea of notebooks. So in in traditional, you just write your SQL code and you write your stored procedures, but with notebooks, they're a bit more diverse, so they're like accessible kind of anywhere off the internet, um, and you can connect different languages to them, so you're not limited to just using SQL. So if you're a SQL developer, you still write in SQL, at least in a Databricks notebook, but you can also write Python code or wrap up your SQL code with Python and give it different sort of parameters and values to kind of enable that metadata-driven cycle as well. Um,
So I guess more accessible for people if they know multiple different languages, you can use them together rather than just have to stick to one.
that's it. So, like, while it's hard to move to kind of the modern approach,
Yeah.
I don't think anyone needs to be worrying about like whether their skills fit in the modern world. Like, you can bring the skills over, and you can still write in SQL if you want to. But I think, especially with like Copilot and things now, like it's quite easy to pick up these new
Yeah.
skills. So you could take your SQL stored procedure and you could ask Copilot, can you change this into Python, even if it's just for you to look over and
Yeah.
kind of learn what you can be doing differently.
You'll always need to review those, but in terms of
Yeah. Yeah.
as a base, it's gonna get you 90% of the way there.
Yeah, and even just from like a learning perspective, you can see like, oh, that's how I do that in Python as opposed to the SQL, just to kind of speed up your learning a bit rather than staring at a blank page of Python.
Yeah. And like, would you recommend moving towards a more Python approach or a SQL, or do you think the balance is what makes it great?
Um, yeah, I think I'd go for a balance. So I tend to use Python more for the like orchestration side of it. Um, but then the individual transformations I might write in SQL just because when you're helping a company go from that traditional approach, all their logic is written in SQL. So it's you can keep their logic in SQL and then just put Python wrappers around everything that you're orchestrating it all from Python. Um, but you're still
Yeah.
get to use the code that exists.
And I guess
Yeah.
one of the great things about SQL is how readable it is. So for those people who aren't familiar, they can still understand what the code is doing, even when you've got the Python enhancements.
Yeah, definitely. And like from a transactional point of view, I find SQL is just kind of easier to know what it's doing
Yeah.
than Python because you have to get your data frame that
Oh,
have
definitely.
a loads of different functions for
Whereas
that.
select from where you can read it and
It's just
understand it.
simple and it's like
Absolutely.
universal.
And as well as the different languages that you can use, you mentioned before about storage of the data. Why don't you talk a bit more about that within the new modern data world?
Yeah, so in the old world, would it be if the data stored in your SQL tables was stored as tables? So if you had a blank spot, it would be a blank spot saved on this
Yeah.
SQL server. Whereas now that we've got um, data lakes with kind of this tabular, like pretend layer on
Yeah.
top, um, it means that you only need to store like what you actually have, and then this metadata layer will kind of read all of your files and be able to interpret them as tables. So you can still use it like it's a SQL database, but it's not under hood. It's all um, just like compressed files. Um,
You've mentioned metadata a lot. What is the metadata layer?
um, so the metadata layer above um, a data lake is basically the thing that enables you to see it as a table. So it's kind of information like what columns it's expecting to read and what data types they are.
Yeah.
Um, so it's just something that a Databricks knows in the background so that it can read those files and understand what that's representing rather than it just being a
Yeah.
load of text.
So it's sort of kind of a summary, just so then it knows how to query that data.
Yeah, yeah, that's it.
And I think understanding this modern data, I guess there's lots of things that you can help to make it really better, but also probably things that you could very easily do wrong, I guess, or just not as efficiently as possible. Do you have any particular examples of good things to do or bad things to not do?
Yeah. So this one is actually taken from a software engineering principle called called dry, which is basically don't repeat yourself. There's something that we see all the time with kind of any data landscape or any bit of code really is um, you write a function or you write a bit of code, and then when you need it for another table, you then write the same bit of code
Yeah.
and do the same transformation. And um, we see this a lot with like pipelines, especially. So in traditional ones, we see, you might have 150 pipelines, each doing very similar tasks of loading in a table and just transforming it a little bit. But they tweak it because this one's doing a different table. So by doing the metadata driven approach, you kind of avoid having all these different pipelines. So you can just have one pipeline that you're feeding information to. And the benefit of that is that if there's an issue with, one of your 150 pipelines, um, are you and it applies to all
Yeah.
150, are
You're
you
going to
gonna
have to refix that.
yeah, like, are you actually gonna go through and fix it 150 times? Chances are you won't, or you'll forget to,
Yeah.
or you just won't be bothered to. And if you leave any that aren't fixed, someone else will find that bug in the future and they'll fix it their way, and we just end up with all this inconsistency. So I think kind of my key message is like, if you find yourself like repeating the same thing, you need to either put it into some sort of metadata driven like config or write it as a function and just call that function. I don't think you should be doing the same bit of code, same bit of logic twice, because it just opens you up to kind of a whole world of
Definitely. And I guess it could come to then different definitions. If you change, for example, what an order is in one table, you need to keep that
yeah,
consistent
yeah,
approach and have that common data model.
yeah. Because I think it's just all just a slippery slope. If you stick to this, don't repeat yourself. It means that um, we won't down the line have issues with business definitions for things. Like it's quite common that
Definitely.
one user's report saying one thing and another's saying another. Um, so if we just from the very start, when you're implementing this, is have this approach of don't implement the same thing twice. Then it means that we won't end up with this inconsistency.
Well, sounds very good and definitely sounds like something to worth giving a try and using all the online resources available. Yeah. Well, thank you very much, Daisy, for coming on and your expertise. And thank you for watching. Don't forget to like the video. If you've got any questions, leave them in the comments below. And don't forget to subscribe to the channel. Thanks. See ya.